Hi everyone. So, how many people here know anything about contextual? Okay, okay. So no hands went up. So it's almost Diego slightly went up. There's almost a clean slate here. So I can tell you something new. So this library and this talk came about because I was giving a talk late last year. I gave a talk in Lyon at Scala-io about interpolating strings. And the problem was that it was split into 4 parts, and the first part was meant to be sort of easy, then the second part was sort of middling, then the third part was hard stuff, and then I ended up with something that even I didn't understand. And the audience were lost sort of 5 minutes in, and the rest of the talk was too complicated for anyone, including Miles Sabin, to understand, which gave me everything I needed to know that this was not a talk I should try and fit into half an hour or 40 minutes, whatever it was. So what I decided to do was take all of the ideas I was trying to explain to people about string interpolation and all the fancy, clever things you can do with them, and put them into a library, and to explain to people that how to use the library rather than the details and the esoteric compiler details as to why it worked. And that became Contextual. And I'll talk you through it. This is something you're probably very familiar with, an interpolated string. So we're substituting a, so I'm going to have to keep turning to look at the screen because I can't see it so well here. I'm substituting a string into another string, and is everybody here familiar with the S interpolator? Any object you put into there, prefixed by a dollar, gets toString called on it, and it gets put right in the string. So that this becomes hello John. Nothing even remotely exciting is happening here. And in fact, I think S interpolators, the ones we probably use most frequently, they're actually very boring. There's not a lot that happens in there. Any type can be substituted into an S interpolator. Doesn't matter whether it's any or whether it's a primitive or more complicated type. They can all be substituted in, and the compiler is happy with it because it just calls toString. And the return type from this is always a string. So if we're in a stringly typed world, then sure, this is fine, but we tend to prefer more complicated types, more structured types. And the third point, which maybe is obvious, you can put any content you like into that string. Any string, any characters can go into that string in any order, and the compiler will be fine with it. So like I said, this is an obvious point, but it becomes relevant later on. Now, what's really happening when we write that S interpolator? Well, if you're in Mirko's previous talk, he mentioned the compiler phases that the Scala compiler goes through. Now, prior to typer, which is the big one, we have parsing. And during parsing, which is one of the very first compile phases, it will see this interpolator. So it'll see code like this, and it will transform it into code like this. It will construct a new string context object, which is part of the Scala standard library, with parameters, repeated arguments, parameters which are strings, which represent the fixed, known, statically known parts of that interpolated string. So in this example, we have hello, which is fixed, that comes from the green bit there, and the exclamation mark at the end. So however many substitutions you have, and we've got one substitution here, the name, there'll be one more parameters to this string context, okay? And then it calls a method on that string context called, in this example, S, but it's whatever prefix you put before the string, before the opening quote. And then it'll pass as a parameter to that all of the expressions you're substituting in. So in this case, just name, but it could be a complicated expression if you wanted. So that is the transformation that happens, and that happens very early on in compilation before the typer. So the typer never sees this this syntax here with the prefix and the quotes. It sees the more familiar code like this. And that means that as long as we can get this code here to compile, we're good. The transformation the parser does is very, very naive. It's blind. It doesn't know anything about types at this stage. So it just does a literal transformation. So our job is to make this compile. And this might be difficult or slightly harder if this S method doesn't exist. And by default, the S method does not exist. But we can use a decorator, and I'll show you that in a second. This is sometimes known as extension methods, to provide the means for that code to compile. So, by the way, who here is familiar with extension methods or decorators? Previously called the Pimp My Library pattern, but that name has been, now you all know what I'm talking about. That name has been deprecated. Right, so we're going to use that later on to provide that S method and make this compile. I'm actually, I'm going to put this a bit higher up because otherwise I will struggle. We've lost power, but we're okay. I don't want the computer to die halfway through. So assuming we implement that extension method on there, on string context, we can then implement that method any way we like. We can change the return type. It doesn't have to be a string. We can give it parameters which have any type. They can be restricted to some non-any type. So they could be strings, they could be integers. And we can have any number of parameters. And normally, it would make sense to allow any arbitrary number of substitutions, maybe 0, maybe 100. But if you wanted to, you could restrict this to only allowing, say, 2 substitutions by defining that S method to take exactly 2 parameters. Meanwhile, my mouse has stopped working. Right, okay. And this last point here, which maybe causes people a little bit of uneasiness, quite rightly, is that we could implement that S with a macro. The feature of macros is completely orthogonal from the feature of interpolators, and there's no reason why we can't do that. Remember, all we're trying to do is make that second line there compile. So let's have a go at this for an equivalent to the S interpolation. We'll call it sub. What we've got here is we've got the implicit class that defines the decorator around a string context, and we're going to provide the sub method. So that takes any number of parameters, that's what that star is there, and they're typed as any. And for each one, we're going to use the string context. This is the object that gets created by the parser, and we will intersperse the. By the way, intersperse is not a method in the standard library, but it would be nice if it was. But we'll just pretend it exists, and we'll use that to alternate between the fixed parts and the substitutions, which we're just calling toString on. And then we call makeString to join all of those together, and the result is if we wrote this code, this would now compile, and it would return hello, whatever name is there. Is that all clear? Anyone? Any questions so far? Okay. That's good. But I've said we're going to try and use a macro to implement this, and a macro gives us a lot more possibilities to open up. We could choose which types. We could restrict which types can be embedded. Well, actually, the type system can do that, but we have a little bit more control with the macro, so we can do more advanced things with restricting the types. We could, and this is maybe the most interesting bit, we can actually parse the literal parts, because at compile time we know what they are. We know what those static parts of the string are during compilation, and we could actually decide whether we succeed, we accept it as valid code, or we reject it on the basis that the string contains something invalid that we want to reject. Now this third point is a little bit different from the first one, because we can actually decide which types can be substituted in which positions. There may be some types which, assuming we have a string containing some DSL, there may be some positions in that DSL where we can accept integers, other positions where those integers are not valid, and maybe strings are valid. So we can configure all of this, and this can be done with a macro. But macros are obviously very hard to write. And I think I just want to refresh this. Well, we've lost the font. I had an additional slide here. Although the font has gone, and so has my extra slide, unfortunately. I'm going to talk you through one example. The example I'm going to talk through is an XML interpolator. Now, XML is quite a complicated example because you can substitute values into that in attribute position, into the body of the XML. Strings are valid substitutions to attributes, but XML, if you wanted to embed XML within XML, as I'm sure you might do, because it's recursively defined, you don't want to be able to embed those XML literals in, or XML in attribute position. So you'll see some examples in a second. XML is just one example. The other slide that's missing gives some examples. You could use this to parse dates and times. You could say I want to reject any date literal that is not in the valid format. You could allow URLs or URIs, file paths, class path references. You could actually check at compile time if you include a class path reference in your code. You could check that that is actually on the class path, or at least will be copied into the class path by virtue of being in a, for example, in SBT's resources directory. These are all things that can be checked. You could go more advanced. You could embed, for example, JavaScript in a string and check that it's well formed. Or why not Lisp or Haskell? Someone has actually written a contextual interpolator for Scala, so you can embed Scala inside Scala. Why would you want to do that? Well, maybe you want to compile it and check whether it succeeds or what the result is at compile time. Maybe you want to check that compilation of a particular block of Scala fails. For example, like the ill-typed macro in Shapeless, and I think now in Scala test. You could embed DSLs for other structured data types like JSON or YAML or protocol buffers, or references into those XPath, JSON path. These are all possibilities. These are all things you might want to represent in code. And what we can do with Contextual is we can reject the cases where you've written that code and we can decide at compile time that it shouldn't be valid. We can actually make it impossible to construct a value which should not exist by virtue of being ill-formed. I've got some other examples. CSS I wrote an interpolator for. and I was able to cross-reference class names in CSS. By the way, who here works with CSS ever and has worked at some point in their career with CSS? About half of you. Okay, half of you is lucky, half of you is not. I'm not specifying which half. Yeah, good point. You could cross-reference class names against HTML to check that if you refer to a class name in HTML, that it has the same name as one in CSS that you've defined. These are all possibilities. But we're going to look at XML. I'll show you a few examples, and a lot of these examples are not so much things that compile, but they're things which do not compile, which I think is in many ways more interesting. Runar Bjarnason gave a talk, a very good keynote at Scala World, the first edition we had, and his I think the title of the talk was "Liberties Constrain and Constraints Liberate." So my job with Contextual is to add constraints to your code to liberate you. The idea is that by constraining what you can write to only the things that are valid, I am liberating you in feeling confident that code will work at runtime without a runtime failure. So we're transferring those runtime failures or potential runtime failures to compile errors to make sure that bad code never actually makes it into the runtime. So first example, there's absolutely no problem with this one here. We can substitute a string, hello world, inside some XML. This is fine. But if we tried to substitute an exception, what does it mean to substitute an exception into something that is string-like? Well, we could call toString on it, but there's no real there are precedents for it, but I don't believe it's ever the right thing to do, just to assume that toString will be suitable. So this will be a compile error. This will not compile with Contextual. But we can also parse the contents of those strings. And parsing without substitution is actually probably many of the use cases of Contextual. You just want to represent something, check it. You don't care about the complexity of putting types from Scala into that. You just want to check that a string is a valid representation of something that you're working with. So the first example is a valid representation of XML. It's an XML node that contains a single self-closing XML node bar. That's all fine. The second one is also fine. A little bit more complicated. So this would work equally well with strings. But in these cases, this is code we could quite possibly write by accident. We could forget to include just here the closing or the self-closing tag. So this is invalid XML. It's not closed. This second one here is also not valid because this baz here is not in quotes. It's not valid XML. And the third one, well, this looks like an expression saying 1 is less than 2, which, I mean, it's even true, but this looks like an opening bracket for a tag. So we want to reject this as well. We want to replace this with, or we would want to manually change this to ampersand GT semicolon so that it's a greater than symbol rather than what looks like syntax. So Xylophone, the XML library which is built upon Contextual, will reject all of these and, in theory, liberate you to not worry about XML. What if we had something like this? I mean, it's reasonable to substitute that as a string right there, and that would be valid XML, but the problem is, in general, we don't know that this does contain the necessary closing syntax for this tag. So we don't know that that's a valid substitution there. It could just contain the word bar, in which case this would no longer parse. So we have to say, because this is variable, this content value here is variable, we just don't know that that's safe to do. So we reject this. And conversely, unfortunately, my screen down here has lost sync with this one up here. But I can move both along in parallel, I think. Yeah, okay. So this example here, if we were to substitute this in here, what is the valid interpretation? Because then we're putting invalid characters in content here. Well, it would interpret that like this, and because it knows about the escaping rules, and it knows the valid escaping rules for that position in the XML, it is safe to convert that to an ampersand GT semicolon, and this remains valid XML. So some more examples. When we're doing substitutions, we can unambiguously, without quotes, put a variable name right there, or an expression of any kind right there. That's no problem, because we have a way of interpreting that. So that is allowed. But if we did put the quotes in there, that's also allowed, because there's no reason not to accept those. But if you think about it, in this version here, we have to wrap this in quotes in order to substitute it in that position. But if we were to wrap this one in quotes, we end up with invalid XML, because we have empty quotes, then whatever the content of name is, and then some more empty quotes. So Contextual gives us a way, and I'll show you a lot of this later, it gives us a way of understanding the context we're in a particular interpolated string, and doing an appropriate substitution for that particular position. This example here is very straightforward. We don't need the quotes at all, and it'll just substitute that string in its raw but escaped form there. However, this last example, where we're trying to use the value as a tag name there, that is not permitted, because in the general case, we need our opening tags to match with our closing tags. And whilst we might be able to make sense of this, I mean, even if the string contained unusual characters or spaces, we could always choose to escape them in some way, to delete them or whatever. In the general case, we don't know that one expression matches, or the expression used for the opening tag matches the expression for the closing tag, assuming both were variable to begin with. So there's various things that are allowed and not allowed there. Additionally, we might want to embed different types. Now, the examples I showed you were all strings. Nothing exciting about strings. And in fact, nothing exciting about doubles, really. But double here is just one example. It could be your own favorite type that you're using everywhere that you want to substitute in certain positions. And Contextual provides this syntax to allow you to extend what you can substitute into an interpolated string. The syntax is we take our representation, our object representing the interpolator, and we call embed, giving it the type that we want to be able to substitute. Now, by default, doubles are not, you can't substitute doubles. So we're going to extend it, maybe in our own application code, not in the library. In our application code, we want to extend it to support substitution of doubles. And we're going to say in body position, we want to substitute the double just by calling toString on it. That's generally safe to do. Likewise, on an attribute, we're going to just call toString on the double again, and we can now have that double inside a quoted attribute. This body here and this attribute are types that represent the different positions you might want to make substitutions in contextual. In this example, in xylophone in the XML. And these lambdas here represent the transformations you do to make the substitution. Now, this is where you would put the escaping. If you wanted to substitute something in a third case here, for example, inside an entity, maybe you want to refer to entities, then maybe you would do some transformation before you do the substitution, and that would go in here. Oh, and it's worth pointing out, this is a type class instance. It's an implicit which should be in scope any way you want to embed these doubles. How many people here are familiar with type classes? Good, most people. So type classes give us a way of defining behavior of certain types sort of after the fact. So this example here of an implicit embedding, this is defining behavior or a relationship of behavior between doubles and the interpolator. And this is being defined in code downstream of both doubles. I mean, doubles are in the standard library, and downstream of the interpolator. So this is a post hoc type class instance that is defining this behavior. So this is very useful. It gives us extension points. We can even be more general. Anyone who's done some more advanced type class work may be familiar with this sort of pattern. We want to embed any type that is itself showable. So any type that has a show type class, we want to say this will be embedded. This can be embedded in body position. And the syntax is very similar, but we take a type parameter there, and we're making our embed implicit generic on that type parameter. So if you're familiar with show, this should be straightforward. If you're not, don't worry about it. It's a more advanced usage. So that was talking through one particular usage and a more advanced usage. And I'm not going to show you any code from Xylophone because it's quite long and it sort of misses the point a little bit. It's good for examples, but not so much for demonstrating how you would write your own. If you wanted to write your own, and I'm going to go through an example here with a URL interpolator. I'd like you all to think about DSLs you work with when you're coding. Something you might like to do checks on before you hit the runtime. So if anyone here is embedding some sort of DSL in their Scala code that is inside a string, try and think of ways you could check that and see how they could fit into Contextual's approach to defining the checks that get run on that during compile time. So there are, I'm going to go through 7 steps here. Each step here is reasonably small and simple, but you do need to do a lot of steps. So it's a slightly involved process, especially if you're including substitutions in your interpolator. We're going to create the interpolator, it's just an object. We'll want to bind it to a prefix. So like the S interpolator, that's bound to S or sub in our recreated version. Maybe you want to bind it to CSV, if you're embedding CSV, for example. You then want to write some code to check the content. Now this is code that is very ordinary Scala code. We will lift that code to run it at compile time, but from your point of view as a user of Contextual, you're going to write some code that does some checks on some strings. This can be anything you like. it can check the internet, it can call out, it can read a dictionary from your local hard disk and check that all the words in your string are spelt correctly, or at least exist in the dictionary. Any code you like can go in here. And if you're doing substitutions, which we will with the URL example, you'll need to define the context. These are the different positions or different parsing states within the string that you maybe want to allow substitutions in. I'll explain that probably better with an example. And then you need to contextualize the holes for your particular use case or for your particular string. That means from the parsing we do, specify how each what position is each hole in that parsed string. And everything up to this point is defining things that happen at compile time. But you actually need to create an object at the end of this. So we're going to define what happens at runtime. That's the evaluation. And then if we're going to allow substitution of types, then we need to specify with the embedding examples I showed you in the previous couple of slides, show you how to show the compiler how to embed different types in your interpolated string. Okay, let's get started. So the first thing, we create the object. It extends interpolator, and that's all there is to it for now. We're going to replace these dots with something in a moment. Binding it to a prefix. This is once again the decorator implicit class, and I've tried to make the syntax as simple as possible without really making it particularly opaque what's going on. But this prefix here is the macro that gets applied. Don't be scared that I've used the word macro, because you don't need to really be aware that a macro is running. But all I would do is, if you want to bind something to a prefix, copy this code. It's 3 lines. Change that to the name of the object you've just created, and change that to the prefix you want to use, and everything else stays the same. Okay? So we're 2 steps out of 7 in already. And then in our interpolator, we want to implement, or we need to, in fact, implement this contextualize method. This is where the library gets its name from. It's adding context to the holes. By the way, you're okay with me using the word holes and substitutions interchangeably? When I say holes, they're the bits that are not known at compile time. Something will go in there, something will be filled in at runtime, but we don't know until runtime what they are. And we're currently thinking in the compile time world, where those things are nothing but holes to be filled in later. And we're going to check the bits we do know about. We're going to check the strings, and we have access to all of those literals in this context parameter that gets passed into the method here. So we can do whatever we like in here, and I'm not going to talk anything. I'm not going to say anything about what goes in there, except that you have access to a sequence of strings, and you can check them however you like. And if you find a problem, if you see something in those strings that you want to reject, you can actually abort the entire compilation by calling abort. It takes 3 parameters. One is the literal in which the failure is happening. So each literal is the fixed bit surrounding the holes. So let's say we've got a problem with the first one. We pass that in there. This integer here is the offset into that literal that we want the cursor in the compile error message to point at. So you can actually work out exactly which character your problem is occurring on and report that back to the user so they know as well. And then there's the custom error message that says, no, you can't do this, fix it, and then we'll try and compile again. So a URL example, this is the sort of thing we would like to be able to parse. I've highlighted in 5 different colors, different contexts. This is the scheme, the domain, the path, the one of potentially many keys, you could have further keys back here, and the value. Now, a hole that appeared here would be in domain, in scheme position, in domain position there. If you had a hole there, it would be in path position. So if we wanted to allow substitutions in here, we would want to be able to specify how those holes should be interpreted. And this is all sort of convoluted means of getting information from the compile time back to the runtime, so that the right escaping can be done, the right rejections can be made if you want to reject certain types in certain positions. Now, in our interpolator, what we're going to do is we're just going to return from our contextualize method a sequence, in this case a list, of those contexts which we've just defined, representing the holes. There's a hole, because we don't know at compile time what that is. There is another hole. This one's in path position, this one's in value position. So, I mean, this is sort of fixed implementation. If you, we would have some code which returns a dynamic list here, depending on what it's actually parsing. But to give an example of the sort of result you would give, we're giving a list of 2 results back, 1, 2, and the context of the first is path, the context of the second is value. And then my next step was to define what happens at runtime. And this is going to be pretty straightforward, but we're going to choose to return a Java URL. Maybe you've got your own favorite HTTP library and you want to use some other type there, but this is in the standard library. All we're going to do in here is use this context, which is now runtime interpolation, so that the static interpolation has access only to the static parts of that code. The runtime interpolation additionally has access to the runtime values. So we know at runtime during evaluation what values have been substituted into the holes. They're no longer holes; they're now substitutions. And using that information, using that context we get there, we can construct a new URL. And we're confident about constructing the new URL from that string, from those strings in there, because we've already made it past compilation, so we know that the contextualize method has run successfully, and we can then construct it safely. So a slight subtlety and something to maybe get your head around is that these 2 methods both defined on the same object. One of them runs at compile time, contextualize, and one of them runs at runtime, and they have different information available to each of them. I showed you an embedding before. We've got several different positions we may want to embed values in. We're going to allow strings, so I've specified string there. We're going to use the syntax again, and most things will be URL encoded. If we try and substitute something into the domain, then there's a load more restrictions on what is a valid domain. So we're going to replace anything invalid with an empty string. I don't know if you'd ever want to have a dynamically specified domain, but maybe a subdomain would be appropriate. In which case, you can't allow spaces or any symbols in there. So we just make that safe. And I've assumed that you're converting things to strings when you put them into the interpolated string. You might want to convert them to more structured types, and in your contextualize method, take advantage of those more that structure you're putting in to maybe maybe do things a little bit more safely. I won't go into much detail about that, and I'm also changing the API subtly to make this safer. But there are more options there. You don't have to convert everything to strings before evaluating it. And there's I've got this slide called the truth here. The truth is much more complicated than this. There is a macro running behind all of this, and if I hadn't been shown the 5-minute sign about 2 minutes ago, I would have told you a lot more details about the what's really happening here. But I'll spare you the complexity. All you need to be aware is that there is a macro going on. You do need to run this as an earlier phase in your build cycle. So that is one constraint of a contextual designed library. But after that, you can use them. You can use them anywhere. It looks a lot simpler than it is, I think, but it does buy you a lot of safety. So it seems like a worthwhile trade-off to me. So to summarize what you're getting here, and I hope the examples I've shown you are at least a little way indicative of that. Contextual makes it possible to define interpolators for custom types in Scala, and provides an extensible API for defining where, when, and how types may be substituted into them. Now, the first half of this might actually cover the majority of use cases, and the first 10 minutes of the talk gave you those examples as well. If you don't have substitutions, life is as easy as just writing a parser for your string. You don't even have to write the parser. You can pull in somebody else's parser, and you can parse whatever content you like at compile time and either accept it or reject it. The complexity, and this is why this is a 45-minute talk rather than a lightning talk, comes with the substitutions and when they're allowed and when they're not. So if all of that all of the things I talked about in the second half of this seemed a little bit complicated and you didn't really follow why I was doing things in that particular way, don't ignore the fact that you can write very simple checks on plain strings using contextual without this complexity. And maybe a simpler way of interpreting it, a library built on contextual makes it impossible to write an instance of a type which should not exist. Assuming you've implemented your library correctly, you can actually make it impossible to construct types which don't exist. Now, that was unexpected. Perhaps an equivalent way of thinking about this, or an equivalent example. Can you store the value 1 plus I in an int? Well, obviously you can't. Why not? Because it's a compile error. Now that's maybe a very basic, a very obvious example, but you can extend that idea to other things. You can make it impossible to write an HTTP URL that only has a single slash after HTTP : because that's a mistake. That's something that can be checked at compile time, and contextual gives you the tools to do that. So I hope that's maybe inspired people to think about some opportunities for adding some safety to their code. We have version 1.01 is out now and is available for every active version of Scala on every platform. And there's a website. The website is Contextual with a dot, 2 characters before and 2 characters before the end and 2 characters after the start. co.ntextu.al. There's a GitHub channel, and I'm reasonably active in there. And you can check the project on GitHub. It's Apache 2 licensed. And if you're interested in working on something, just send me a tweet. I'm @Propensive, and I'm happy to help people get implementations working. So I'll leave it up there if anyone wants to get. You've got your photo. Thank you. And with that, I will say thank you, and I'll take questions.